Hi everybody, Denny here from ColdQuanta. Welcome to 3 Minutes of Quantum Computing. Last week we ran the 4x4 Star Battle QAOA on Qiskit's Chasm simulator. Today we'll look at the algorithm in a bit more detail. QAOA is a form of variational algorithm, which is something you may have encountered in a quantum mechanics course. A variational algorithm builds a wave function which depends on some parameters. If we sandwich a Hamiltonian between a wave function and its conjugate transpose, the result is an upper bound for the lowest eigenvalue of the Hamiltonian. If we vary the parameters in the wave function, then the expectation value will vary too, and the set of all those expectation values will be an upper bound for that lowest eigenvalue. QAOA proposes a particular form of variational wave function shown here. The S state is a superposition over all computational basis states. We multiply it by a unitary derived from the cost Hamiltonian, which has been exponentiated after multiplying by a parameter gamma. Then we multiply it by another unitary called the mixing operator, which contains a parameter beta. This pairing is repeated some number of times, indicated here by the parameter p. What's p? P is for precision. The number of variational parameters in our wave function is 2 times p, a beta and a gamma parameter for each unitary. And the more parameters in a variational wave function, the more of Hilbert space it can reach, giving us a better answer. Here's a graph taken from a recent Google publication showing QAOA on some simple problems. This shows the expectation value of the Hamiltonian in the variational wave function as we vary the beta and gamma parameters. The star on the left marks the best value for the parameters, and the trajectory on the right shows the progress of the classical search as it varies parameters. This is for p equals 1, since there is only a single beta and gamma parameter. It's important to note that QAOA is a hybrid algorithm. There is a classical and a quantum portion to it. The classical portion is responsible for managing the search through the space of beta and gamma parameters, and the quantum portion executes the QAOA circuit for each set of parameter values determined by the classical search. Check out the GitLab site for some beautiful Jupyter notebooks, which will show you all the steps we took to run this problem. Here's where we start building the QAOA. Here's the 8x8 Star Battle puzzle that started this project. And here's the 64x64 NumPy array containing the QAOA representation of that 8x8 puzzle. At ColdQuanta, we're building a quantum computer on which we'll run this problem and others soon. Once our prototype is running, we'll be back to show you how it works, so stay tuned. That's it for today. Thanks for watching. Bye everybody.